Hello everyone and welcome to Rasayan Academy. So this is another video in the 4-mark question series basically for the CSIR as well as GATE exam preparation. Okay. Alright guys, so let's start with our video for today. So let me introduce myself a little bit. My name is Jagriti Sharma and I'm also an educator on the Unacademy platform, as you already know. So if you visit my profile and if you follow me, you will be able to get regular updates about the upcoming courses. And guys, I have made a lot of content on the Unacademy. I would definitely suggest you to visit the classes. And if you follow me, you will be able to get regular updates for the special classes, which are free live classes, which are free 1-hour live classes. Okay, and everyone is able to attend them. It is free, so you just have to follow me. You just have to register for the class. You will get a notification and you can just join my class. Okay, it's that simple. Alright, so if you are not able to attend any of my live classes, then you can see the recordings. So these are the recordings which are available over here. Also, let me tell you very quickly about my upcoming courses. So I'm going to have a batch course which starts from 8th of January. Basically my classes which are going to be on stereochemistry as well as organic reaction mechanisms. So it is going to start from 8th of January. Okay, and I will be taking organic chemistry in the batch course, and Nurul sir will be taking inorganic and SD sir will be taking physical chemistry. Alright, so basically a combination of all the subjects is in the batch course, right? Along with that, side by side so yeah, along with that, I'm also having my individual course, which is in which I'm going to complete organic chemistry for the CSIR NET exam, as well as GATE exam, because guys, the syllabus is almost same, and after every class we are going to have a doubt session, we are going to have a practice session and so on. So right now the course has started from 3rd of January and we are studying carbenes, reaction intermediate carbenes. Okay, so guys, if you want to subscribe, I've already made a video on how to subscribe on Unacademy basically, and what are my courses and classes in the month of January. I've already made a video, so you can use my code Jagriti S, and using a code gives you 10% discount basically. Okay, so never forget to use the code of educator, and if you're not able to apply the code by any means, then you can ask the support team. Basically there's a support team on Unacademy. You can ask your questions from that as well. Okay, so guys, let us begin this video with our first question. So this is the first question for today. What is the major product in the following reaction sequence? So as always, I would suggest you to stop the video and try to understand the question, try to get the answer by yourself. Okay, so alright, I think you have seen this question. I think you have tried it out by yourself. So it's a very simple question, guys. The major product is asked in the following reaction sequence. So first of all, we are given a cyclopentanone. Along with that, the tetrahydropyrrole is given, and it is a base. We know that it is a base. Okay, also, what is the first reagent? It is para-toluene sulfonic acid in inert solvent basically, which is our benzene, and also there is heating. So right guys, para-toluene sulfonic acid, what is the function of para-toluene sulfonic acid? Basically it is just a strong acid. All right, it's just a strong acid which is being provided into the solution. So the first combination of reagent is only providing a strong acid which is providing a lot of H plus. Okay, so in the first condition we are only providing H plus into the system. And what will be the possibility when we are providing acid? So the ketone system, the oxygen is definitely going to take the H plus and it is going to form the oxonium ion, something like this. Yes, it is going to form the oxonium ion, something like this. And here there is a possibility of attack from the nucleophile, which is our nitrogen, on the carbon. This carbon becomes very electrophilic. Okay, and we can get this type of a intermediate. All right, and there is H over here, so definitely nitrogen becomes positive. So ultimately guys, this oxygen can also take up a proton from the acidic medium. This proton can be taken up by water. So basically there is a proton exchange which is going on and ultimately it can help the water to get removed, and this is going to generate our imine. I hope that you have studied this reaction. It is going to generate an imine like this, right? Also, when we are, the whole reaction is carried out in the acidic medium. So there is one more possibility that we are also having alpha hydrogens over here on both the sides, which can give us a very stable, enamine. Right, so this is our enamine formation which takes place. Okay, all right. So I'm just going to move further. So basically I've just shown you that from the cyclopentanone we are forming the enamine basically in the presence of an acid as well as our tetrahydropyrrole basically. Okay, now what happens? Now the second reagent which is given, let me take you back to the question. The second reagent which is given is our chloroform in the presence of a base. And right now guys, we are having our we are already studying about carbenes in the batch course, so we already know that by alpha elimination it is going to generate dichlorocarbene. Okay, so this reaction is alpha elimination, that there is a base OH minus grabbing this acidic proton, और उसके बाद में there will be a carboanion which will be formed, a carboanion which will be formed like this, and it is a very stable carboanion because there are 3 chlorine groups which are having minus I effect. So the greater minus I effect of 3 chlorine group is actually helping the carboanion get stable. Now the Cl can be removed. Cl minus, when it is removed, it is going to give this carbene. And guys, as we know कि ये mechanism ionic mechanism है, so it is going to be singlet carbene. Alright, because it is an ionic mechanism, it is going to be a singlet carbene. So now what? The reaction is very simple. To if we consider the enamine as the enol system, because the enol system is also something like this. Okay, the enol system is also something like this, that the oxygen is assisting the double bond to attack over an electrophile. So this system is also very similar to enol system, but it is just enamine. Okay, also guys, we know that dichlorocarbene is also, basically carbenes are electrophilic in nature and it will be attacked by the pi bond. So the nitrogen over here in the enamine is helping the pi bond to attack over the carbene, and whenever a pi bond attacks a carbene, ये जो non-bonded electron pair है, this becomes negative charge basically. Okay, so we have discussed this in more detail in our sessions basically. Alright, now what will be the further mechanism? So guys, if you have studied the Riemer-Tiemann reaction of the carbene, basically of the carbene addition, basically orthoformylation over phenol, then you would know that this proton will be taken up by the carbene carbon itself. Okay, and you are going to get something like this. So there will be a, if this proton is taken, there will be a negative charge over here. All right, on this carbon there will be a negative charge, there is a hydrogen, there are 2 chlorine like this, negative charge falls back and the positive charge which was developed on nitrogen is stabilized back again, nitrogen gets its lone pair back again. So this is what we are having. Okay, now what will happen? Ultimately the nitrogen is going to push back again for the removal of one of the chlorine groups, and ultimately it is going to give you an intermediate. So basically I have already drawn a lot of things over here, so I'm just drawing it in this corner. Alright, so basically there will be a double bond and there will be a double bond over here, hydrogen and chlorine. And now by the attack of water, or let's say if still we are having a lot of base in the medium, by the attack of a base, it can still attack over this carbon, and the whole process goes on, and the reaction mechanism is exactly similar to Riemer-Tiemann reaction. It is exactly similar to Riemer-Tiemann reaction. If you have if you know that reaction, you will be able to do this very easily. So ultimately what happens, we generate our hydrogen over here, something like this. Okay, let me just show you that it is so it has already given two OH groups because both substitution has taken place. Pi bond भी remove हो गया है. It has become the imine system, and after hydrolysis of the imine as well as this is our देखो कोई भी जब दो OH ग्रुप होते हैं कभी भी हमारे पास में on the one single carbon, it is not very stable. So geminal dihydroxide is not stable at all. So it is going to convert into aldehyde, okay, and also by the hydrolysis of the imine bond, it is again going to give us the starting compound, which was our carbonyl. So this is what will be the product of this reaction. Then, so guys, ultimately there are three steps which are involved in this reaction, in the whole reaction. So this is our answer basically. Yes, it is not a carboxylic acid, it is just formylation. So let me just explain this to you once again. What are the three major important steps in the whole reaction? So basically the first step was enamine formation in the presence of H plus acid. Second step was carbene formation by alpha elimination, and also the enamine attack over carbene. First of all, the carbene had formed by alpha elimination. The second step was enamine had attacked over carbene. Alright, and also the third step will be the imine hydrolysis. Okay, this is our third step to give back this carbonyl compound. Okay, so these are the major three steps which are asked in this question and which is going to result to our product X. I hope that you have understood this. I hope that you will try it out by yourself as well. Okay, so the next question is, which of the following is optically inactive? Okay, so in this question this is asking which of the following is optically inactive, and over here we are not given our tetrahedral carbon in all the options. It is only there in option number D. So this is our tetrahedral carbon and it is having all four different groups. One is hydrogen, OH, COH. So definitely this carbon becomes chiral because it is having all different groups. Similarly, if we look at option number C, so over here we see that this is alene type of system. This is alene. And what kind of alene is this? We are having two phenyl rings on two different carbons and two methyl groups. So definitely this is also a chiral compound due to a chiral axis. So we say that it is due to a chiral axis. So this is also chiral alene system. Okay. Now we have two other options. So both of them are going to be chiral as well as they are going to be optically active. What about option number A as well as option number B? So guys, basically what happens, a phenomenon which is called flipping. Okay, so there is a phenomenon which is called flipping. Okay, so it is possible in the case of nitrogen when there is a lone pair and the shape of nitrogen, or let's say this compound, is pyramidal. Basically the shape of this molecule is pyramidal. Okay, and what is the possibility? The lone pair can squeeze inside, or basically the lone pair can squeeze through nitrogen and come down, and all of the group can go up. It is like, you know, it is like the flipping of an umbrella. So umbrella is usually like this. Okay, so but it can flip when the air is very strong. It does flip. Okay, so that is flipping. Okay, so because of flipping, what happens? See, this is one compound, this is one, let's say, chiral compound for the nitrogen, because all the groups are different, isn't it? There is a phenyl group, there is a methyl, there is a ethyl group. So basically it can this isomer of, or let's say this conformer is chiral because all the groups are different and there is a lone pair which is definitely different. Okay, But the thing is, because of flipping, what happens, the isomer, the exact enantiomer, or let's say the exact mirror image is produced. Because if we are putting this molecule below this one, below the first one, we will be able to see that it is the exact mirror image. It is the exact mirror image. Let me just draw it for you. Okay, so I'm drawing the same molecule over here. Alright, so this is our CH2, CH3, and this is the lone pair. Okay, so because of flipping, what happens is, because of flipping, the exact enantiomer is formed, and when both the enantiomers are present in the same mixture, then 50% of racemization occurs. So basically, one conformer is optically active, but because of the flipping, both the enantiomers are formed in 50%, and that is why racemization occurs in the case of the nitrogen basically. Alright, so this is definitely optically inactive, and inactive due to racemization. Okay? Also, let me tell you, what about phosphorus? So what about the phosphorus compound, guys? So basically, if we go back to the question, so first thing about phosphorus compound is that the angle in between these two in nitrogen is basically something around 105 to 107 degrees. Okay, but the angle in between these group in the case of it can be phosphine, it can be some other triphenyl phosphine, for example. Okay, so any kind of phosphine is having a lesser angle as compared to nitrogen. It is mostly around 92 to 95 degrees. Okay. Alright, so because of that angle, and if you have studied the chemical bonding, you would know that phosphines show bit of more p character in their bonds and less of sp3 character. Okay, so I hope that you have studied this. And guys, what will happen because of the smaller bond angles, the rotation is not very, or let's say the flipping is not very spontaneous as compared to nitrogen. Okay, because nitrogen is flipping really fast. एक तो इसका angle already बड़ा है, and to flip is very easy, right? So if the angle is already like large, to flip is also very easy. But for this phosphorus, the angle is small, right? The bond angle is small, so for it to flip, it is going to take a lot of energy, right? So the rotation, or let's say the flipping energy barrier is higher for phosphorus. Also because of the bond angle is small, also because the groups are bulkier. Okay, phenyl group is there, alright, but the group, it is methyl over here, and this is our allyl group over here basically. Okay, this is a CH2 and this is CH double bond CH2, basically allyl group. So first of all, this is a bulkier group over here, and second thing is कि जो bond angle है वो भी छोटा है यहाँ पे, so flipping is not very fast as compared to this one. So we can say it is optically active at room temperature. Yes, so it is seen to be optically active at room temperature because it is slow in flipping, while the ammonia, or let's say the nitrogen compound, is very fast in flipping, and that is why it terms optically inactive due to racemization. Alright, so A is our correct answer over here. Okay, now let us see one more question. So what is the H-NMR spectrum of 18-annuline? So basically the NMR spectrum, the proton NMR spectrum of 18-annuline shows which of the following is the correct option. So option number 1 is one peak at 7.2 ppm, okay, for 18 hydrogens. So basically 18-annuline is having 18 hydrogens, but all of them are showing only one peak, that too at 7.2 ppm. Is that true? Yes or no? Let's see. Only one peak at 5 ppm for all the hydrogens. So the first thing that we have to know, guys, that the 18-annuline system is having some inner protons as well as it is having some outer protons. Okay, so if you know about the anisotropic effect, if you know about the de-shielding effect, of when the magnetic field is applied to an aromatic system, what will happen? The outer electrons, sorry, the outer hydrogens, or let's say outer any group which is having proton, it can be direct hydrogen, it can be methyl group attached. So they are going to be much more de-shielded as compared to the inner. The inner ones will be shielded. So definitely the value cannot be the same for all the 18 hydrogens. So option A and B are wrong. What about option C and D? So two peaks at delta 9.0 ppm, 9.0 ppm which is for the 12 hydrogens, and delta -3 for 6 hydrogen. Okay. In option number D, 9.0 ppm for 6 hydrogens, and it is -3 for 12 hydrogens. So now let us see which hydrogen will be shielded and which hydrogen will not be shielded. Okay. Alright. So let us see the structure over here for the 18 aniline system. So this is our 18 aniline system which I have already drawn. Okay. So guys, over here as you can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So there are 12 outer hydrogens. So these outer hydrogens will be de-shielded more as compared to the inner ones, and we are having 1, 2, 3, 4, 5, 6. So we are having 6 inner hydrogens. Okay, I hope that after looking at the structure it becomes more clear to you that what are the number of outer as well as inner hydrogens. So basically guys, we have to remember for 18 aniline we are having 6 inner hydrogens and 12 outer hydrogens. So outer hydrogens will be more de-shielded, so it is going to have a higher ppm value, and the 6 inner hydrogens are very shielded, so it is going to have a very low ppm value. Okay, and let's see in the options what do we have. So in the options we are having that the 6 hydrogens which are the inner hydrogens and the 12 outer hydrogens. So the 6 hydrogens are having -3.0 and the 12 outer hydrogens are having 9.0 ppm. So definitely answer C is the correct answer, because the inner hydrogens are more shielded as compared to the outer ones. Okay, so it is going to have such a high de-shielding value, 9.0 ppm, and it is going to have the inner protons having such a low value. It is -3, which is even less than the standard TMS value, even more shielded than the TMS protons. Okay, alright, so C is our correct option and D is also wrong. Alright guys, I hope that you are able to follow. And these were the questions for today, and if you like this video, please give it a thumbs up. Also share it to your friends and also subscribe to my channel if you haven't already. So basically I am an educator on the Unacademy, right? So you can follow me over there for more detailed discussions, as well as there is a lot of content that we are creating on the Unacademy for the CSIR exam, for the GATE exam. Alright. And right now on the Unacademy's YouTube channel, which is called Unacademy Live, Unacademy Live. So on that channel also I am having sessions, and for the whole month of January I'm going to focus on the GATE previous year questions, as well as practice questions, okay, for the upcoming GATE exam. So I hope that I will help you over there as well. So thank you so much guys, and follow me on Unacademy as well as watch Unacademy Live YouTube channel also. And over here please like, share and subscribe, and also give me suggestions on what topics, or let's say which questions you are getting trouble into. So I will try to solve them as well. Thank you so much for watching this video. I'll see you in the next video. Thank you.